Hi guys, so I decided to write out the homework solutions step by step on a video so that way you guys can follow along, pause the videos you need, and are able to see more clearly on the process of answering word problems. So first things first, we're going to read it and underline what is important. So a football is kicked, the height of the football in feet, so feet, is dependent upon the number of seconds. Since it was kicked, the function represents the situation. So our function we see is h of x equals 2x times the quantity of 19 minus x. So the first thing you might notice is this is not in quadratic form. We don't see a variable that's squared, so we have to distribute our 2x to rewrite our function. And if you want to pause the video here to rewrite it and then see if our answers match up, go ahead. So it would be rewritten as h of x, oh, just poked a hole in my paper. So 2x times 19 is going to give us 38x minus 2x squared. We know that we always like to write our functions with our x squared at the front to put it in standard form. So we're going to have negative 2x squared plus 38x. So that is our new function. So now we're going to look at our A through D. So first we're asked, what is the maximum height of the football? So the maximum. So if we remember that when we look at our A value, right, if it's less than 0, we are going to have a maximum. And if our A value is greater than 0, we are going to have a minimum. So if we look here, our A value is negative 2 with our x squared. So we know that we are going to have a maximum, as the question asks what the maximum height will be. So we know that the maximum occurs at the vertex. So in order to find the vertex, we know to find the x value, we use the formula of negative b over 2a. So again, if you wanted to pause the video at this point to work this out, if you haven't already done so. So if we look back at our original function, our b value is 38, so negative 38 over 2 times our a value of negative 2. So we know that our value is going to be positive, and we wind up getting 19 halves. When we simplify negative 38 divided by negative 4, simplified gives us 19 halves. I just skipped that step of simplifying, but you guys can work that out on your own. So we know that x is time. If we look back, number of seconds since it was kicked is x. But the question is asking us what is the maximum height. So we know that we have to find our y value of our vertex. So if we use our x value of 19 halves in our function, wherever we see x, we're going to write 19 halves. So we're going to have negative 2, 19 halves squared plus 38 times 19 halves. Sorry for my handwriting. I'm pushing up against the books that I have stacked to hold the phone right now. So when you simplify this out, I'll let you guys do that on your own. We are going to get a solution of, just move it over a little bit, 361 halves, which can be written in decimal form as 180.5 feet. So like I said, you guys can work that out, make sure that you get that y value, and that is part A. So now if we move on to part B, after how many seconds does the ball reach its maximum height? Well, we know that the vertex determines the maximum height that's reached. We know that x is in terms of seconds, and we actually just found that right here. So we know that our x value is going to be 19 half seconds, which is equivalent to 9.5 seconds. So we know after 9.5 seconds, we are going to reach the maximum height of 180.5 feet. Now we move on to part C, which is asking us after how many seconds does the ball hit the ground. So when a ball hits the ground, we know that we have a height of 0. So when we have a height of 0, we know that our function h of x represents height, so we're going to set our whole function equal to 0 to solve for x to find the time at which the ball hits the ground and has a height of 0. So I would suggest using the function in factored form that we were originally given, because we know using the zero product property, we can just set each factor equal to 0 and solve for x, and we're going to get two values of x. A little easier than dealing with the negative 2x squared plus 38x, which we would then have to factor, and we were going to wind up getting back here anyway. So we are going to set each of our factors equal to 0. So 2x equals 0. 19 minus x equals 0. When we divide both sides by 2 here, we have x equals 0. When we add x to both sides here, we get x equals 19. So at 0 seconds and 19 seconds, the ball is going to hit the ground. So we know that if it starts on the ground at 0 seconds, we want to know after it's kicked where it's going to wind up. So after 19 seconds, it will be back on the ground after it's hit. So your answer here in the context of the problem is going to be 19 seconds. And then for part D, we didn't really discuss domain, so we're just going to ignore that one, and that's number 1. So at this point, if you wanted to pause, review what we just did in number 1, go back, more than welcome to do so. We're going to move on to number 2. So I'll slide my paper up so you guys can see. All right, so just adjust this. There we go. So number 2. The electric consumption for Gotham City from noon until noon, so that's important, from noon until noon, the following day can be modeled by the equation 1/8 times x minus 14 quantity squared plus 10, where x equals the number of hours since noon, and E is the total consumption. So we know that our x values are going to be number of hours since noon, and our y values are going to be the total consumption, as E represents our function. So if we wanted to label the axes of our graph here, we could say our x-axis is going to be time in hours, and we know that it's hours since noon, and then our y-axis is going to be total consumption. Just get that off the bat from reading our word problem. So then part A asks us, at what time does Gotham City use the least amount of electricity? So when we think of least, we know that that would be the minimum, right? And like we talked about in number 1, we know that based on our A values, if our A value is greater than 0, we're going to have a minimum. So if we look here, this is actually given to us in vertex form. So if we were to distribute all of our values to get it into standard form, we would see that our A value is our A value is greater than 0, so we do have a minimum. You guys can work that out if you wanted to take our function. You would distribute x minus 14 squared by foiling, then multiply everything by 1/8, add 10, and you'll get to standard form. Just for sake of time and sake of space, I'm not going to do that right now, but your function will give you a minimum, as the A value will be greater than 0. So we know that our minimum, again, is located at the vertex. So since this is in vertex form, right, as I said, we know that we can find our vertex as hk when given vertex form. So if we look here, our h value is negative 14, but we always know that when we write h, it's the opposite sign that's given in x minus 14. So our h value is going to be positive 14. Again, opposite sign of what you see in the parentheses. And then our k value is what's given plus 10. So our minimum is going to occur at the coordinate 14, 10. But we have to look back. The question is asking us, at what time do we reach the least amount of electricity? So time, if we look back at our problem, is going to be in terms of x, number of hours since noon. So we know that after 14 hours after noon, we are going to have our minimum. 14 hours since noon is going to be 2 o'clock a.m. If you count 14 hours past noon, you will get to 2 o'clock a.m. Again, using what we know of the vertex based on vertex form to answer in the context of our problem. So now if we move on to part B, what is the y-intercept of the function and what does it mean in the context of the problem? So to find the y-intercept, we have to set x equal to 0 because we want to solve for y. So we're going to have our function 1/8 of 0 minus 14 squared plus 10. We've set x equal to 0, and we are now going to solve for y. So when we simplify this, you guys can pause here, go ahead and simplify, work it out yourself. So we're going to have y equals 69/2. Again, you would follow the order of operations, PEMDAS. I think you guys are pretty good with that. So you would do 0 minus 14, get negative 14 squared, times 1/8, then you add 10, you wind up getting 69/2. Can be rewritten as 34.5, so we know that our y-intercept is going to be the coordinate 0, 34.5. What does this mean in the context of the problem? So we know that x represents number of hours since noon, and we know that our y values represent the total consumption. So if x is 0, that means that no hours have passed noon, which means that at noon, the city has consumed 34.5 kilowatts. If we look back in our problem here, given in kilowatts, 2 T's. And that is the context of our y-axis. So we're also given a graph.